All right, this is the chapter 9, section 3, geometric sequences. Your learning objective is to define, identify, and apply geometric sequences. If you read the essential understanding, it says, in a geometric sequence, the ratio of any term to its preceding term is a constant value. I would never talk like that in my real life, so I put it in layman's terms. So what they're trying to explain to you is that if you have a geometric sequence, that means it increases by the same multiplier each time. To find the common ratio, divide the term by its previous term. For example, 6, 18, 54, etc. The common ratio is the term divided by its previous term, which I picked 8 and 16 because to me that was the easiest to divide. So 18 divided by 6 is 3. So logistically, a geometric sequence has a starting value and a common ratio. And each time you multiply by the common ratio. To write a recursive formula, you always start with your first term. Then, any term that comes after that, you take the one before it and multiply by your common ratio. So anytime you're writing a recursive formula, you have to put down your first term. So A1 equals. Always on a recursive. Then this little baby n-1 just means take the term before and multiply it by r. The explicit formula, which I happen to love explicit formulas because it helps you find the term no matter where you are, is the first term times the common ratio to the power n-1 for any n's greater than or equal to 1. All right, so we're going to do some examples. We're going to identify if the sequence is geometric, and if it is, what the first term is and what the common ratio is. So we're gonna say geometric or not and find A and R. So in the sequence 2, 4, 8, 16. Am I multiplying by the same amount each time? So we're going to work our way backwards. 16 divided by 8 is 2. 8 divided by 4 is 2. 4 divided by 2 is 2. So the sequence is geometric. And our common ratio is 2. And what is our first term? We look at 1, 5, 9, 13, 17. 17 divided by 13. 13 divided by 9. 9 divided by 5. And 5 divided by 1. Are all these equal ratios? 5 over 1, 9 over 5, 13 over 9, 17 over 13. No. Because the ratios aren't the same, it is not a geometric sequence. Okay, take a look at this one here. 2 to the 3rd, 2 to the 7th, 2 to the 11th, 2 to the 15th. We have to determine, is that geometric? All right, so we need to check our ratios. So we have 2 to the 15 over 2 to the 11. and I believe that's 2 to the 4th. We have 2 to the 11 over 2 to the 7. It's 2 to the 4th. 2 to the 7 over 2 to the 3rd. 2 to the 4th. So this one is geometric. Our ratio is 2 to the 4th, and our first term is 2 cubed. All right. One of the areas that you'll use geometric sequences in is finding missing terms. So in 3, comma, we don't know what, comma, 12, we want to find out what the second term of the sequence is. All right, so we need to figure out a common ratio. That way, that when we multiply it, gives us this number and then 12. So let's try, what do you guys want to try? I'll give you a hint, not 1, because 3 times 1 is 3, and 3 times 1 is, so not going to be 1. What else do we want to try?
3 times 3.
3 times 3 is
9.
9, and 9 times 3 is 27. So it's not 3. So let's try 2. 3 times 2 is 6, and 6 times 2 is 12. Yay! So the second term in this geometric sequence is 6. And in fact, if we want to find a missing term and we have the 2 right next to it, there is a formula we can use. Let me see if I wrote that down. Yeah, this is blank. And there's nothing there. I guess I didn't write that down. Maybe, oh, okay. It's right here. I did write it down. I knew I wrote that somewhere. Okay, so the geometric mean of 2 positive numbers is what we did up here. X and y is x times y, and then take the square root. So let's see how this applies here. So we got 3 times 12 square root. We did it with our noggins where we were just thinking, oh yeah, it's going to be 6. But if we use this little formula, it's 3 times 12 is 36, and the square root of 36 is 6. We have a little bit of a problem because we know when we take the square root, it creates 2 possible answers. Another answer could possibly be that it's -6. If my common ratio was -2, so if I had 3 times -2 is -6, and what is -6 times -2? Positive 12. So when you're using geometric mean, you have to list both possible answers. Could be positive, could be negative, because multiplying by a negative in a geometric sequence, you're going to get every other one is negative. So we can't discount that option. All right, so the 9th and 11th term of a geometric sequence are 45 and 80. What are the possible values for the 10th term? I know it's not necessary, because I know I'm using geometric mean. It's not necessary to write it out, but my brain longs for a picture, so for me it's always helpful to write out what I'm doing. So we are going to take 45, times it by 80, and then take the square root. the answer we get for that will have a positive and a negative value because we have to account for both scenarios. So 45 times 80 is 3,600, and the square root is 60. And in fact, the answer could be negative 60 as well.